Question 12, part A. Here we've got parametric equations involving sine and cos, and we're asked to find dy by dx at t equals pi over 6. Okay, so here we should know that dy by dx is equal to dy by dt over dx by dt. And let's see then. So if we're differentiating y equals 1 minus cos 2t, that's okay. Differentiate 1, it disappears. Differentiate minus cos. Well, if we could do a little, we can do a little clock around here. So differentiating, so we're going clockwise around. Differentiating minus cos. So if you differentiate minus cos, you go to sine, positive sine that is. So positive sine there. Differentiating, no chain rule. We've got the inside function of 2t. Differentiate 2t, you get 2 on the outside there. Okay, so that's the numerator. Dx by dt, so differentiate 2 sine t, differentiate sine, you get cos. Okay, so that's simply 2 cos t. Now, at t equals pi over 6 then, what are we getting there? So we're getting 2 sine of 2 lots of pi over 6, well that's pi over 3 over 2 cos t, which is pi over 6. Okay, now clearly the 2's cancel, and then sine of pi over 3. Now sine of pi over 3 is root 3 over 2, and you can do that on your calculator if you needed. Cos of pi over 6, well that's also root 3 over 2, so you've got root 3 over 2 divided by root 3 over 2, well that's just going to be 1. Okay, here we have what we're looking for here. We're looking for the Cartesian equation here between the two parametric equations. Now, what we ideally want to do is express the y function there. We've got a cos 2t, so we might be able to do something with that. And in fact, we can over here. We did it earlier in the homework. Cos 2t can be written as 1 minus 2 sine squared t. Okay. That's from the double angle formula for cos, so I explained it earlier in the homework. Now, that then means that we can express this bit here as 1 minus 2 sine squared t. Sine squared t then is sine t all squared, and if we make sine t the subject of that, then we could do some substitution work. So that's the plan. So first of all then, replace the cos 2t with 1 minus 2 sine squared t there. Tidy that up a little bit, so we've got a minus 1 and then minus minus, so plus 2 sine squared t. 1 minus 1 is 0, so we're left there at the minute with 2 sine squared t. Okay, now that's for y. Now meantime over here for x, rearrange that to make sine t the subject, making sine t equal to x over 2 there, dividing through by 2. Okay. Now if it helps, just remember that sine squared t is actually sine t all squared. When written like that, and you know that sine t equals x over 2, hopefully you can see that simply substitute the x equals x over 2 into that position there. And you're left with a Cartesian equation for linking x and y. You might want to tidy this up, or tidy up anyway, and change the format a little bit. So if you square it out, you get a squared over 4, and then of course 2 over 4 would simplify down to a division by 2. Division by 2. So y equals x squared over 2. A further element of this question was the domain for the Cartesian function. So here we had y equals x squared over 2. The original domain in terms of t was between minus pi over 2 and pi over 2. Now we want a domain for x. So what I've done here, I've sketched the graph of x equals 2 sine t. so a stretch of 2 in the y direction, or what is normally the y direction anyway, the vertical direction here. So between minus pi over 2 and pi over 2, so the domain for t there, so the horizontal axis now is t, minus pi over 2 to pi over 2, the vertical axis is now x, and this is our sine curve between what is normally minus 90 and 90 sort of thing. Okay, so as you can see there then, in that range we have x coming out as minus 2 up to 2, and therefore our new domain is minus 2 to 2, and therefore in terms of the question, k equals 2. Okay, part 2 of the question was about the range. The range is obviously the y values. Now the Cartesian equation we worked out earlier was y equals x squared over 2, and the domain we worked out earlier was between x being between minus 2 and 2. Now if you sketch y equals x squared over 2 between those limits and x, you get this curve here. Okay, so it's effectively y equals x squared with a stretch of a half in the y direction. The limits there, the x limits anyway, minus 2 and 2. Going into the y function here, 2 squared is 4, divided by 2 is 2, so it comes out as a y equals 2. I've highlighted therefore the actual function, because none of this therefore is technically part of the function anymore, because they're outside the original domain of x being between minus 2 and 2. So then in terms of the y values, the output values now, you can see that the lowest value is 0 and the highest value then is 2. So y is between 0 and 2, or if you've written it as f of x, for example, you could write it as f of x between 0 and 2, for example.